Welcome to this lecture over the transport layer, which is Chapter 4. We're going to talk about what the role of the transport layer is. We're going to talk a lot about TCP and UDP, Transmission Control Protocol, and User Datagram Protocol. So what it is, how it helps us, and what is the difference between the two. So what is the purpose of the transport layer? The transport layer's mission is to do kind of exactly what the name says, and that is transport data between layers. So in this slide, you will see, I'm trying to find my definition here in my book for you. The transport layer segments and reassembles data into a data stream. So basically what happens is they take upper layer applications and unite them into the same data stream and establish a logical connection between the sending host and the destination host on the network. And then they go in and talk about TCP and UDP, which we'll get to. So in this slide, you'll see application data coming down, network data coming up. The transport layer prepares application data for transport over the network and processes network data back up into the upper layers to be used by the application layer, and then convert that into the application that you're using. Moves data between applications on devices in the network. That's pretty much what I just read to you, so we'll move on. So you'll see here, requires protocol properties, and they have two different sides of this slide. So we have telephony, VoIP, and streaming video. And then on the other side, we have like email and web traffic. So on the left side, the telephony and video, we need it to be fast, low overhead, does not require acknowledgments, does not resend lost data, and delivers data as it arrives, which is probably a little bit backwards than what you're used to thinking about. Because most of us think VoIP, well, we need to have all of the conversation happening. So we need to have acknowledgments that it's been sent. We need to have it resent. So it's probably a little backwards than what you're used to thinking about. And then on the right-hand side, the POP clients, the email and the HTTP, it needs to be reliable, resend lost data, and deliver data in the order that it's sent. So application developers, people who are developing the application products, they choose the appropriate protocol based on the nature of the application. So over here on the left-hand side, they don't have this on here yet, but the IP telephony streaming video is UDP, and the right hand of the screen, the reliability and data sent, is TCP. Here is a breakdown of what the TCP and UDP headers look like. So before we had talked about having the data and what happens. Well, now we're getting into breaking this down and segmenting this data out. So as we do that, we add in these header fields. So you'll see source ports, which we talked a little bit about in last chapter, ports 23, ports 80. So that's where you see that. And then you'll see a bunch of other things in the TCP segment. I have in a book a nice printout, a definition that I'm going to copy off and post on the handouts page for you so that you can read through all the definitions, like the sequence number, acknowledgement number, window, checksum. It'll explain all of that a little bit better. And since we only have 10 minutes here, I'm going to skip right through this. This slide shows you it's a breakdown of the previous slide. So here we saw source port and destination port. Now you can see where that goes in. So POP 110, HTTP 80, IM 531. So that's going to be in that port section. Divides data into pieces, so segments it out, and adds a header into each one of those pieces. So you have big bulks of data, and you're going to break that down. into that TCP UDP format. Here's a picture of the TCP header fields. So this is what things look like. And then you'll notice down here is the actual piece of data that's being sent. But all of these boxes up above are all flagged and have information in them that allow for deliverability. Then we have, these host and destination ports. So people sending TCP requests. Server responds to the clients with random port numbers to be the destination, and those stay in there. That's how data is able to be delivered once it enters out into the world of the cloud. Handshake. So this is the handshake to establish a session. So I'm A, you guys are B. I'm going to send the FIN. You're going to receive it. You're going to acknowledge that you got the send and send it back to me. I'm going to accept it as received. Okay? Then you're going to send a FIN. I'm going to receive it. I'm going to acknowledge that I received it and send back that acknowledgement back to you. So it's similar to in class. Picture me walking into the classroom and saying, hello, where is Daniel? And so I've sent that. You hear it, so you've received it. Daniel's going to stand up and say, whoa, that's me. So you send the acknowledgement back and I receive it. So you see how that process works? So that's what happens in a TCP session. We need to have this connection established. So in networking terms, this would be like the modem. You turned it on. You established a connection, you were able to get on the internet, do what you needed to do. When you were done, you hung up, and the line was open again, and your phone lines could ring. Okay? So when it's terminated, you both stop talking, the session ends, the end of the modem there. How are sequence numbers used? So in TCP, you'll notice one of the definitions was that it needed to be sent in the same order. It needed to be received in the same order that it was sent. So all of these segments have this sequence number in its heading. And that way, when it goes across, if it gets mixed up in the big open cloud here of passing through routers when it comes back to the PC, then it looks at those segment numbers and puts them back in order so that it can send it up the OSI model in the correct path. And you'll see acknowledgement windows. These are flowing, so as long as bytes are being delivered, the window could open, the sizing window could open. When it starts to drop and have issues, then it sizes the window back down. And the acknowledgements talk about how many bytes are in each one of those segments of data so that it knows which segment to send next. So here's talking about the acknowledgement numbers and the window size and congestion and flow control. So if segments are lost because of congestion, then the window size will be reduced. So again, this is not like the first one was 11 bytes. This one's 1500 bytes. It's a moving window to try to help stop with data loss. So this is emails, those kinds of things. You don't want to be losing them. TCP is connection-oriented, so it has to agree upon in advance the path paved for reliable communication to take place. It's complicated, needs error checking, needs to put all of the segments back in sequence when it gets to the other side. Unlike UDP, this is low overhead, just needs to be fast, just need to be able to get the data across and send it. So before I told you, you'd probably be confused about VoIP or video and needing all of those segments, but that's not the case. You're sending it fast. If you miss a pixel, you're probably not going to know that in a video. What you will notice, though, is if your bandwidth is slow, you'll notice that it's rendering and it's trying to catch up and it's trying to put the picture in place. But just missing one tiny piece of information isn't going to stop you. So in UDP, a connection is not established before sending. breaks the packets down and just sends it out as fast as it can get it out. It's a scaled down economy model known as a thin model. Doesn't offer all the bells and whistles, but it does do a really good job of transporting data that doesn't require a lot of reliability. So here you can see datagrams may take different paths, things might get lost, it might get mixed up, but they're not reordered. If you lose one, so in here datagram 3 didn't come across, it's not going to resend it and come ask for it to be sent again. Again, using port numbers to be able to deliver to the proper service or application as it moves up its way in the chain. You'll see source and destination again. So this is the role of the transport layer. Those are two huge protocols, TCP and UDP. If you don't understand some of those concepts, go out and read some more or ask me, and I can get you a couple of pages here that will help explain some of that. Okay?